Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. This week in astronomy, earliest known black hole found. Clumpy galaxy in early universe and stars born tilted. Earliest known black hole found. A group of astronomers from around the world, led by scientists at the University of Texas at Austin's Cosmic Frontier Center, has found the most distant black hole ever confirmed. This black hole is inside a galaxy called Kuiper's LRDZ9, which existed just 500 million years after the Big Bang. That means we are seeing it as it was 13.3 billion years ago, when the universe was only about 3% of its current age. Because of how far back in time this is, it gives scientists a rare chance to study what the universe was like during one of its earliest and most mysterious phases. The team explains that this is about as far back as it's realistically possible to detect a black hole with today's technology. While some more distant black hole candidates have been found, none have had the clear and unique light pattern that confirms a black hole's presence. This pattern is identified using a technique called spectroscopy, which splits light into its different wavelengths. In the case of a black hole, astronomers look for signs of gas moving very quickly. Gas falling into a black hole shifts light from one side toward red wavelengths and light from the other side toward blue wavelengths, due to its high-speed motion. There are few things in the universe that produce such a pattern, and this galaxy shows it. The discovery was made using data from the James Webb Space Telescope, JWST, specifically from a program called Kuiper's, which focuses on studying the earliest galaxies. JWST, launched in 2021, can see farther into space than any other telescope. One of the goals of Kuiper's is to confirm the distances of very old galaxies and study their physical properties. Kuiper's LRDZ9 was first spotted as a tiny red dot in telescope images, and later identified as part of a recently discovered type of galaxy called little red dots. These galaxies only existed within the first 1.5 billion years of the universe and are unusually compact, red, and bright. Their appearance was surprising to astronomers, as they looked completely different from galaxies seen by the Hubble Space Telescope. Scientists are still working to understand what they are and how they formed. The new discovery strengthens the idea that supermassive black holes may be the reason little red dots are so bright. Normally, such brightness would mean a galaxy has many stars, but at that time in the universe's history, it's unlikely they had that many. Black holes, however, can shine brilliantly by heating and compressing the material they consume. The confirmed black hole in Kuiper's LRDZ9 provides a clear example of this. It may also explain why these galaxies are so red. One theory is that thick clouds of gas around the black hole change the color of the light passing through them, shifting it toward the red. The patterns seen in this galaxy match those from others where such gas clouds have been detected. This black hole is extremely massive, with up to 300 million times the mass of the Sun, making it almost as heavy as half of all the stars in its galaxy combined. Finding such a large black hole so early in the universe's history challenges existing theories. Either early black holes grew far faster than expected, or they formed already much larger than scientists thought possible. The researchers now hope to get sharper, more detailed observations of Kuiper's LRDZ9 with the James Webb Space Telescope. This will help them learn more about the galaxy, its black hole, and what role black holes played in the formation of little red dots. They see this as a valuable object for studying how black holes evolved in the early universe, something they could only begin doing very recently. Cosmic grapes, clumpy galaxy in early universe. Astronomers have found a very unusual galaxy that existed only 900 million years after the Big Bang. This galaxy, nicknamed the cosmic grapes, is rotating and made up of at least 15 large clumps of stars forming all at once. That is far more clumps than scientists thought could exist in a single rotating galaxy so early in the universe's history. The discovery was possible thanks to detailed observations from both the James Webb Space Telescope and the Atacama Large Millimeter/Submillimeter Array. The galaxy also happened to be perfectly positioned behind a giant cluster of galaxies, which acted like a natural magnifying glass through gravitational lensing. This combination allowed astronomers to study it in extraordinary detail, using more than 100 hours of telescope time. When seen before with the Hubble Space Telescope, the galaxy looked smooth and disc-shaped, with no sign of anything unusual. But with the much sharper vision of JWST and ALMA, and the extra magnification from gravitational lensing, astronomers saw something completely different. The galaxy was full of bright, dense clumps packed together like a bunch of grapes. They also discovered that the clumps were all within a smooth, rotating disk of gas, with parts of the disk moving toward us and others moving away, just as you would expect from a spinning galaxy. This galaxy is not some rare, extreme case. Its size, mass, star formation rate, and chemical makeup all fit with what astronomers consider a normal galaxy for its time. That means many other galaxies that look smooth to us right now could actually be hiding similar clumps, invisible until we have the tools to see them. The discovery is challenging current theories of galaxy formation. Computer simulations do not predict that so many large clumps should exist in early rotating galaxies. This suggests that our ideas about how galaxies build themselves, and how energy and matter interact in their early stages, may need to be rethought. The cosmic grapes give scientists a rare look at the building blocks of galaxies in the young universe. Researchers now want to find out whether many other galaxies from that era looked like this, which could change our whole picture of how galaxies grew in the universe's early days. Some sun-like stars are born tilted. Scientists from several universities discover that many stars similar to our Sun are born with their rotation axis tilted compared to the disks of gas and dust around them, which are the birthplaces of planets. These disks, called protoplanetary disks, are present around all young stars, but until recently little was known about how their orientation compares to the star's own spin. For a long time, people assumed stars and their disks start off aligned, based on the fact that our Sun's spin axis is mostly aligned with the orbits of the planets in our solar system. This new research challenges that old assumption. Astronomers have known since the 1990s, when the first planets around other stars were found, that some planets have orbits at steep angles compared to the spin of their stars. This was surprising and led scientists to propose explanations. One idea was that after planets formed, gravitational effects from a passing star, a companion star, or a massive planet far from the star could tilt the orbits. The main belief was that stars and planets start aligned, and these tilts happen later over billions of years. But there was also the possibility that the misalignment was present from birth. To investigate, researchers studied 49 young, isolated stars with their protoplanetary disks, using data from the ALMA telescope, the TESS Space Telescope, and the Kepler K2 mission. They measured the angles between the stars' rotation and their disks. They found that about 2/3 were aligned, but about 1/3 were tilted from the start. This means that some planetary systems don't need complicated explanations involving later interactions, they simply form tilted. There are still cases where complex gravitational interactions are needed to explain extreme tilts, but this study shows that our Sun's slight 6-degree tilt could just be a natural variation from its birth. The next step is to figure out why some stars and disks are born tilted while others are not, since the reason for this remains a mystery.